The other thing is that once you train the network, you won't save into disk question.
Are you going to discuss network types other than sequential today?
Today, we probably not talk, but in the future, for example, RESTnet, we're going to talk about block rather than sequential. But to create network, usually either you use block or using sequential. But you can parallel, but don't. Well, hybrid sequential, that's a good question. We maybe cover in the future lectures. Like the hybrid sequential means it's almost like sequential, but hybrid sequential means you can get network you can call hybridize and get some, like you can think cafe-like definition, but it's on JSON, and you can grab the network and deploy into another language rather than Python, for example. So that's why MSNet is called mixed net. Actually, it's mixed imperative and the symbolic. So we only talk about imperative. That is, usually people, researchers, or do with deep learning. But if you're an engineer, you're going to deploy the models beyond Python, then you can use hybridize to get another language. Okay. So once we have the pre-trained networks, we're going to save into disk. Sometimes if you train very large networks, we're going to save frequently. For every data epoch, we usually dump the parameter into disk. There's two reasons. One reason, at the earlier day, the GPU can burn out at any time. Well, if a GPU is the fan is not so large, you need to install a lot of fan on the machine. And if the degree is higher for like 1 hour, then the GPU have a lot of chance to burn out, like give errors. So it's good for you to save all the parameters from time to time. The second reason is that sometimes you train at the middle range, you see, oh, it doesn't converge. Well, it doesn't converge properly. And I can see the training curve. It happens at the particular range. So I can stop the training job. I'm not necessarily starting from scratch. I can start it from the middle. I change the learning rate and start from middle. So that's why you see that a lot of research paper, for example, the Inception paper we're going to talk about after 2 weeks. It's a very famous network from Google. In the network, well, they have been in the ImageNet competition. Then the report is like, yes, we cannot really remember how this network is from because we just train network, change it, stop, and from the middle and train another one, and a lot of sequential, and you can. Then I really don't know how to trace back to the from scratch. So that is, it's always a good idea to save the parameters from time to time. Okay, here to save them is pretty easy. For example, if an ND array, you can call .save, you can save to a file. nd.save, and given the ND array, I save it to a file. And then I load back the file, I can give another x2, which is equals to x. Also, I can save a list. I give a list of x and y, and load again, I can load into x and x2 and y2. Also, I can save a dictionary. Remember that the parameter is actually a dictionary. We can save the dictionary directly. So it's a dictionary. We save into my dic, and the load back is another dictionary. For Gluon, here we define a network as similar as before. Then we initialize it and run the for function. Then we just call net.save underscore parameters. So we save into something called here. So all the parameters, all the weight are going to saved, but not the network. The network itself will not saved. Question?
These Gluon serializations, what kind of format are they using?
Serialization is just a binary. It's not. It's not compressed. Just the memory binaries. It's not compressed, so which means if the parameter take 100 megabyte in memory, you're going to have 100 gigabyte in disk. But it's just a raw memory, so it's pretty fast. It's much faster than the Pico in Python if you don't do anything there. And also it's cross-language, which means you can load back into different language as well. And note back, yes, I need to get a definition of the network, and the node parameters just replace my parameter with the one I node from disk. So you can see that these two guys, given the same input, the output will be similar. So here, for the previous question, why the hybridized version will let you to know the network definition as well. So kind of like something node, my MLP.json kind of do that one. So you don't need to remember, you don't need to save the Python code. You can also cross different language. Okay. Okay, that's all for to save parameters.